Hi everyone. So today we're going to be doing a bit more examples on the washer method. Then on Monday, that's a public holiday. So I'm going to post a video instead of having a live lecture. Okay, it will just be a couple more examples on the washer method. And then when we start again on Tuesday, we're going to do the new section on the shell method. Yeah. So that's the plan for now. Okay, let's take a look at some more examples. Okay, so number one. Okay, like always, I need to give you the setup and then we can go from there. Okay, so we've got the following setup here. We've got the function root x and the function x squared, so that looks like that. So on the top, we have root x, y equals root x, and at the bottom, we have y is equal to x squared. Okay, and we know that they intersect at 1, 1. So we're going from 0 to 1. Okay, so this is the area that we're interested in. And we want to rotate this around a different axis now. We're going to rotate it around the axis y equals 2. So let's just draw the axis here. This is y is equal to 2. Okay, and we're rotating around this axis. Okay, so last time we rotated around the x-axis or the y-axis. Now we're rotating around y equals 2. Okay, very similar to what we did in the disk method, where we rotated around a different axis. Okay, so same thing as always, we need to find the inner radius and we need to find the outer radius. So the inner radius will be the distance from the axis to the first curve. So that is going to be this distance over here. So that's going to be our inner radius. And then the outer radius will be the distance from the axis to the outer curve. So that's going to be this distance over here. That is the outer radius. Okay, so we need to work out what these distances are. Now we know that the total distance is going to be 2. Okay, so the distance from the x-axis to this line y equals 2, that's going to be a distance of 2. Okay, if we just make a little mark here, this distance over here is going to be root x, because that's y equals root x. Okay, and then this distance here up to our y equals x squared function, that distance is going to be x squared. Okay, so if we know all those distances, we can find r in and r out. Okay, so we know that r in plus root x is going to be equal to 2, because that's the total distance. So that means r in is going to be 2 minus root x. Okay, that's the first one. And then we know r out plus x squared is going to be equal to 2. So r out is 2 minus x squared. Okay, so we've got our inner radius and we've got our outer radius. Now we can find the volume. So the volume is going to be equal to the integral from 0 to 1, because we're stacking from 0 to 1. Okay, then it's going to be pi r out squared minus r in squared dx. Okay, because remember, we are stacking horizontally, so the integral is in terms of x. Okay, so this is going to be pi times the integral from 0 to 1. Okay, r out squared is going to be 2 minus x squared, all of that squared, minus r in squared, that's going to be 2 minus root x, all of that squared, dx. Okay, so now this is just a straightforward integral that we can then solve. Okay, so let's expand this out so we get nice exponents to work with. So this is the integral from 0 to 1. Expanding the first bracket gives us 4 minus 4x squared plus x to the 4. Okay, expanding the second bracket gives us 4 minus 4x to the half plus x dx. Okay, so I've just expanded the two binomials we've got there. Okay, so let's collect like terms and then integrate. Okay, so we're going to have minus 4x squared plus x to the 4. Then the plus 4 and the minus 4, they cancel, so we don't have to worry about those. Okay, then we have plus 4x to the half, and then minus x. Okay, so integrating this, very easy. That's going to be minus 4 over 3x cubed plus 1/5 x to the 5 plus 4 times. We add 1 to the exponent to make it 3 over 2, then divide by 3 over 2, so times by 2 over 3, x to the 3 over 2 minus 1/2 x squared. Okay, and this goes from 0 to 1. Okay, so let's substitute 1, because if we substitute 0, we get 0, so we don't have to worry about that. So this is going to be pi into minus 4 over 3 plus 1 over 5 plus 8 over 3 minus 1/2. Okay, so what's the common denominator for all of this? So we have 3, 5, and 2. The closest denominator we're going to get is 30. So let's write everything with denominator 30. So this is going to be minus 40 over 30 plus 6 over 30 plus 80 over 30 and then minus 15 over 30. Okay, so we've got that. Okay, now we can simplify. So this is going to be pi 80 minus 40 minus 15 and plus 6 all over 30. So that's pi 80 minus 40, that's going to be 40 minus 10, that makes it 30, 25. So we have 25 plus 6 over 30. That's going to be pi 31 over 30 units cubed. Okay, so then that gives us our volume. Okay, but like I said before, once you've done this first part here in yellow, then the rest is just simple integration. Okay, so the key idea here is to find the inner radius and the outer radius. You substitute that into our formula, and then the rest is just integrals. Okay, very simple integrals here. Okay, are there any questions about this example? Okay, so it's not too bad. Okay, any questions? Okay, let's take a look at the next one. So number 2. Okay, so let's just give you what the setup looks like. So we have x and y. We have the straight line, y equals 4 minus 2x. So that means this is 4, we've got 0, that's 2. Okay, so we've got this line and we're rotating around x equals 3. Yes, that's x equals 3. Okay, so we want to rotate around here. So if we were to just do a quick little sketch of this, it's going to look something like this. So this point over here, if we rotate around this vertical axis, we're going to get a nice big circle. Same with this bottom point here, we're going to get a circle. Okay, so that gives us a cylinder. Okay, but this point rotated around gives us a smaller circle on the inside. And then that is connected up by this line. So it looks something like that. Okay, sorry, just give me a second, please. Sorry, the internet says it's unstable, so I just want to change it quick. Okay, shouldn't be too long. Okay, that should work. Okay, let's carry on. Okay, so we've got this area here. There we go. We rotate it around and we get this kind of cylinder shape. Again, with this hole. So this is open on the inside. Okay. Are there any questions about how I sketched this? Okay, so everyone's okay with going from the diagram to the sketch? Okay, so let's find the inner radius and the outer radius. So remember, the inner radius is from our axis out to the first curve that we see. So that's going to be this distance over here. That's going to be R in. And the outer radius is from the axis to the outer curve. So that's going to be this distance over here. So that's R out. Okay, we need to find what these distances are. Now we know the distance from the y-axis to this x equals 3 line. This total distance here must be 3. Okay, so that whole thing is 3, which means the outer radius is also 3. Okay, is there anyone that doesn't see that? Okay, good. So now we just need to find the inner radius. We know the total distance is 3. If we can find this green distance here, okay, if we can find the green distance, then we know that the inner radius plus the green distance is 3. Okay, so how do we find that? Well, we know that y is equal to 4 minus 2x. So y minus 4 is equal to minus 2x. So 2x is equal to 4 minus y. So x is equal to 2 minus 1/2 y. So that's the green distance. Okay, so it's going to be 2 minus 1/2 y. So if that's the green distance, then the blue distance, the R in, will be 3 minus that. Okay, because that's the leftover. Okay, so 3 minus 2, that's going to be 1, and then plus 1/2 y. Okay, so we've got the outer radius, and now we've got the inner radius. Are there any questions about how I got that? Okay, so everyone's all right with that. Okay, so we've got the inner radius, we've got the outer radius. Now we can just plug into the volume formula. So the volume is going to be the integral from 0 to 4, because those are our y values here and here. Because remember, we are doing vertical stacking, because the rotation axis is vertical, so we integrate along y. Okay, because that's our vertical direction. then we have pi r out squared minus r in squared dy. So that's going to be pi times the integral from 0 to 4. R out, that's just 3. R in, that's 1 plus 1/2 y, but all of that squared dy. Okay, so let's just expand this out and then we can integrate. So that's going to be pi integral from 0 to 4, 9 minus 1 plus y plus 1/4 y squared dy. Okay, so I've just expanded the binomial out. Okay, so let's just simplify this a bit more. So we have pi integral from 0 to 4, 9 minus 1, that's going to be 8, minus y minus 1/4 y squared dy. Okay, good. Now we just have to integrate and then evaluate. So that's going to be pi integral of 8, that's 8y minus 1/2 y squared minus 1/12y cubed from 0 to 4. Okay, so let's just substitute now. So we're going to have pi 8 times 4 minus 1/2 4 squared. Sorry, I said 1/2, but then I wrote a quarter. So 1/2 4 squared minus 1/12 4 cubed. Okay, so we've got all of that now. If we substitute the lower bound, everything's going to be 0, so we don't have to worry about that. So this is going to be equal to pi 8 times 4, it's going to be 32, minus 4 squared, that's 16 over 2, minus, and then we have 4 cubed over 12. Sorry, just give me a second here. So that's 64 over 12. Okay, so now we want to simplify. So it's pi 32 minus 8 minus 64 over 12. That gives us pi 32 minus 8. That's going to be 24 minus 64 over 12. We can divide top and bottom by 4 just to simplify. So 64 over 4, that's going to be 16. 12 over 4, that's going to be 3. Okay, common denominator of 3 now. So 24 times 3, that gives us 72 over 3 minus 16 over 3. Okay, and then last step, 72 minus 16, that's going to give us 56 over 3 pi. And like I said, if you want to write units cubed, because it's a volume, you can do that, but I'm not too worried about that. Okay, so here we get our final volume answer. Okay, so very similar to what we did last time. Just over here, it's a bit trickier because we're not rotating around the y-axis, we're rotating around a different axis. Yeah, but the same thing applies. You still need to find the inner radius and the outer radius. Okay, but it's just a bit more work finding the inner radius and the outer radius, but exactly the same as what we had last time. Okay, any questions on this one? Okay, so everyone's all right with this example. Okay, let's do one more example today, just with this different axis stuff. Okay, and then we can leave it for today. So example 3. Okay, and then I will just write out the homework problem, for that extra bonus mark that you can get. Okay, so the setup again. Here's our XY axes. Oh, someone's asked a question here. Can you repeat? Number 2. Okay, sure. I can repeat number 2. Okay, so let's just clear this. Okay, so we're doing number 2 again. Okay, so if we just go back here to see what it was. So we had this line y equals 4 minus 2x. So that looks something like that. Y equals 4 minus 2x. And we are rotating around the axis x equals 3. So that's somewhere there. Okay, we're rotating around there. So that's our axis. There's our curve. There's the area of the curve of the region, if you want that. If we rotate this around the axis, this top point here, if we rotate around, that's going to give us a large circle. This bottom point here, if we rotate that around, we're going to get the same kind of circle. If we rotate this around, we're going to get a smaller circle on the inside. Okay, so that we just connect that up. That's this line here, this line here, this line here. And the slanted line, this line here, that's going to join our 2 circles up like that. Okay, so that gives us our 3D shape. But what we're interested in is finding the volume. So how do we do that? We've got our curve, we've got the axis. So now we need to find the inner radius and the outer radius. So we go from the axis out to the curve. So we've got this distance here. This is the inner radius. So if we just draw our axis here, that is this distance here. That's the inner radius, and then the outer radius. Okay, so that's the inner radius there. This is the outer radius here. Okay. Is that part all right? Finding the inner radius and the outer radius? Are there any questions about that? Okay, cool. So now we need to work out what these distances are. Now we know that this is at 3. So we're going from 0 to 3. So the outer radius is just 3 because it covers the full distance. So R out is 3. What about R in? Well, R in is a portion of the total distance. There's still this distance left here. Okay, this green distance there. We need to figure out what that green distance is. Okay, so this green distance is just the x value of this curve, of this line. Whatever the x value is, that's the green distance because it's our horizontal distance there. So just do a bit of working on the side. Y is equal to 4 minus 2x. Now we need to solve for x because that's this distance there. Okay, the green distance is x. Okay, so we're going to have 2x is equal to 4 minus y. Okay, and then x is equal to 2 minus 1/2 y. Sorry, not 4. Yeah, sorry, there we go. So here, this gives us our green distance x. Okay, so now we know R in plus x is equal to 3. Okay, actually, let me put that in green, then you can see, I mean, the green distance. Okay, so R in plus this green distance x is equal to 3. So that means Rn is equal to 3 minus x. So that's going to be 3 minus 2 minus 1/2 y. So that's going to be 1 plus 1/2 y. Okay, so now we have R out and we have R in. Okay, are there any questions about that? Okay, so you're out with that? Okay, so we've got the inner radius, we've got the outer radius, we can then find the volume. So the volume is equal to the integral from 0 to 4, because 0 to 4, that's the y-intercept there. So we're going from 0 to 4, pi times r out squared minus r in squared dy. Okay, so then that's our formula. So we just need to substitute. So this is going to be the integral from 0 to 4. You can take the pi outside. R out squared, that's just going to be 3 squared, minus r in squared, that's going to be 1 plus 1/2 y, all of that squared, dy. So that's going to be pi integral from 0 to 4, 9 minus 1 plus y plus 1/4 y squared, dy. That will be pi integral from 0 to 4, 8 minus y minus 1/4 y squared dy. And then everything after that is exactly the same that we did before. Okay, is that all right now? You okay with this question? Okay, you still confused or are you okay now? Okay, awesome. Okay, I think we're running out of time now, so let's just give you the homework question and then we'll see who can answer it for that bonus mark. Okay, so it's homework question. Okay, so we've got the curve y equals 3 minus x squared. And the line y is equal to 2. Okay, so those are the two curves. Find the volume if we rotate the enclosed area around the axis y equals minus 1. Okay, so there's our homework question for 1 bonus mark for next week's tutorial test. Okay, so we've got y equals 3 minus x squared, y equals 2. Take that enclosed area and we're rotating it around the line, y equals minus 1. Okay, so exactly the same as we had before. The first person to post a full correct solution on the WhatsApp group will get 1 more mark out of 15 for next week's test. Okay, and just while we're talking about that, remember next week's test will cover what we've done this week. So it's going to be on the disk method and the washer method, okay, that we've just finished off today. Okay, so 15 marks, written test, same as we had last time. Okay, are there any questions about that? Okay, cool. So then let me just take a photo of this for the group and then we can call it a day. Okay, so the questions on the WhatsApp group now as well. So first person to provide a full correct solution, you get 1 bonus mark. Okay, so just remember, no lecture on Monday, so that's a public holiday. I will upload a video though, just doing some more examples as revision for your test on Wednesday. And then we will carry on with the new work on Tuesday. Okay, so I'll see you all on Tuesday. Enjoy your weekend. Bye, everyone.